Good afternoon, everyone, and welcome for this webinar series. Thank you for joining us for today's session. The theme and the topic of today's webinar is One Material, One Package, Advancing Sustainability with All PET Closures and Bottle. As sustainability expectations continue to evolve, the focus is clearly beyond recyclability, enabling true circularity while still maintaining performance, product security, and operational efficiency. So, in today's session, we will explore two things. Number one, how an all PET bottle and closure approach can support this transition. And number two, we'll also look at how innovations in closures design are contributing to improved tamper evidence, better capping performance, and also system level efficiency, along with opportunities for lightweighting and cost optimization. So joining us today is Michael White, Director of Business Development for Closures at Husky Technologies. Michael brings over 20 years of experience across product management and marketing, with a strong focus on beverage closure technologies and global market development. He has been closely involved in introducing new injection molding solutions and advancing Husky's closures portfolio worldwide. So before I introduce Mike, I would like to just request the audience to use the chat box that you have in the bottom, where you can put in your questions. Those questions will be answered by the end of the webinar. Mike will be answering those questions. So you have a Q&A box. That's where you'll have to put in your questions. So without much ado, Mike, thank you for joining us today, and over to you.
Thank you, Ben, for the warm introduction. I have to say that was warmer than where I am today in Toronto, where it's currently minus 6 degrees Celsius. It's springtime, but it's not showing its face yet. So again, good morning, good afternoon, good evening, wherever you may be. Thank you for the privilege of your time. I want to take a few minutes today to talk to you about a new and exciting technology that we have developed here at Husky. And that is the PET closure. Now, there are three key things that if I would like you to walk away from this webinar with. One is the focus on enhanced consumer security, which our solution provides, the improved capping performance that it provides, and also the fact that this PET closure is fully compatible with a wide range of industry standard neck finishes. Now, similar to our HDPE portfolio of closures, we're starting with a specific focus on still water, and we will continue to grow that as we journey along. But if you could keep those three things in mind, and I will be touching on each of those in more detail in the coming slides. So, first state of affairs here, I want to talk about the current state. Today we have the current state is a HDPE closure that is affixed to a PET bottle. That is the current state. Typically, while the both materials are recyclable, only the bottle is recycled into food contact applications. The closure as it exists today is typically downcycled into non-food contact applications, whether it's lawn furniture, pails, industrial containers, home personal care products. And really what our vision is to have a mono-material package, i.e. PET closure, PET bottle, that truly enables that true circularity within the circular economy. So as the product's consumed, recycled, remanufactured, it stays within that circular loop. Now, when we set out on this journey to develop PET closure, there was basically 4 key areas that we wanted to focus on with no compromise relative to the current state that exists today, i.e. the HDPE closure. So if we look at on the safety and experience aspect, we wanted to have the industry's best tamper evidence approach. And I will get into how we achieved that and why we believe it is the industry's leading TE approach for consumer security. Also, we wanted to make sure that any solution that we introduce is satisfying the EU Directive 2019-904, which is the tethering legislation that was passed back in 2019 and came into effect almost 2 years ago in Europe. And we see other jurisdictions across the globe that are looking to introduce similar measures. One of the most recent examples I can think of is Australia, specifically the state of New South Wales, which will be implementing tethered in 2030. So again, this is something that has started in Europe and we expect to be adopted in other geographies. So we wanted to make sure that any solution we introduce complies with that legislation and future legislations. The next is capping performance. We want to ensure that we set a bold goal that we need to have capping performance better than the current approach with HDPE. And again, I'll get into more details on how we achieve that. And then on the performance side, we wanted to ensure that there was no compromise on the sealing, anything related to impact resistance, opening torques, or removal torques for the consumer, that they were all within the brand limits. When we look at weight, there is a mass density difference between PET and HDPE, so approximately 40%. So we wanted to make sure that whatever we did in terms of lightweighting got us as close as possible to HDPE. And there's some innovative approaches that I'll describe as we get into the presentation as well, on how we were able to take further weight out relative to the current state that exists today. And we believe that there's a lot more runway for lightweighting just because of the differences in material relative to HDPE. When we look at the design side, we continue to remain with, and our specialty is injection molding. The approach with our slide technology really allows us unconstrained freedom when it comes to the design. So you can look at this tethered option that's a design that's in front of us here. You can see the intricate geometry here on the slides that we can form in the mold without any post-mold operations, i.e. slitting or folding, and that just gives us much more design freedom in incorporating more complex geometries. And you may ask, why do we want more complex geometries? Well, it's more to enable a better consumer experience, and I'll get into that. And then finally, on the compatibility, we wanted to make sure that whatever we offered was fully compatible with the industry standard neck finishes for water, for CSD, and also juices and sport drinks and teas. So let's look at tamper evidence and the purpose of tamper evidence. Really, it's to indicate that the product has been either tampered with or previously opened. And there's really three key areas on any closure that you have here. You have the shell, you also have the bridges, and the bridges are the little connectors that connect the shell to the tamper evident band. And the band itself is retained onto the neck finish, and then eventually, as you start to unscrew or untorque the closure off the neck finish, the band is restricted from movement from the pilfer proof. So it actually, the bridges start to stretch and elongate and deform as the strain is put on them, as through the unscrewing action, excuse me. And as that happens, eventually they reach a point where they fracture and when they remove, you see evidence of the band remaining on the neck finish itself. And really, there are a lot of stakeholders when we look at this that demand a very high level of tamper evidence performance. Obviously, the consumer. The consumer is a key stakeholder there. You want to make sure that your product that you're about to consume is safe for opening and hasn't been opened previously by someone else or some other method. The brand owner has a high stake in this as well. Any kind of bad publicity or negative publicity around tampering or product contamination has a negative impact on the consumer confidence in the brand itself and the trust. So they're definitely a stakeholder. The retailer, where the product was purchased, and especially if the retailer has their own line of beverage products as well. So they're a key stakeholder. And then finally, the producer of the closure itself. If a product has been tampered with and it's been determined that the closure producer was at fault for this product or was one of the parties implicated, they have a very vested interest in ensuring that their product is safe. So I want to go back in time. You may remember, now this is not a beverage example. However, it really highlights the importance of tamper evidence. So we're going back more than 40 years to Chicago. Tylenol, which is a acetaminophen painkiller, typically used for headaches and joint pains, etc. They had an issue where there were some unscrupulous individuals that were tampering with products and were actually lacing the product with cyanide. And Tylenol was one of the pioneers in this space to actually incorporate a more robust form of tamper evidency. Now, they used a different approach with like a vacuum seal or induction seal on the product. Also, then in the secondary packaging, it was glued as well to incorporate additional measures to improve consumer safety. But unfortunately, because of this event, some people died, and J&J was hit. The parent company of Tylenol was hit with a lawsuit of $240 million, equivalent to almost $1 billion in today's money. So not only the consumer pays a price on the health side, but there is a financial impact to those other stakeholders, either in the form of lost revenue, enterprise value, and negative publicity and consumer trust. So that's why tamper evidency and the importance of tamper evidency as it applies to beverage closures is so important. And I want to get into now some examples or our approach on that. And here on this slide here, I just did a quick Google search on just pulling up a few examples, and even this is prevalent today. You can see here counterfeiting, bistillary water, tampering with the product. These are things that are happening, just last year in some examples. Other examples that I posted here happened quite a while ago. But again, not only the tamper evidency is important from a health perspective, but also from an anti-counterfeiting perspective as well. And fortunately, with the approach that we're taking and that I will get into to describing, I think we've solved that challenge in a very successful manner. So I want to give you some insights into some of the challenges that we had when we first developed the PET closure. So what I have shown here is a close-up X-ray scan here. during the capping process with a traditional molded in bridge HDPE closure. So as the closure is applied to the neck finish, you have on the tamper band, and now this is the closure here is kind of translucent. You can see the cam, the outshape or the outline here of the cam itself. So this cam makes contact with the pilfer proof here on the neck finish. And as the closures continue to be applied, it makes contact and starts to stretch. Now, HDPE can absorb a fair amount of plastic deformation as it stretches around the neck finish itself. So it makes contact and stretches around until it snaps into place. So this cam is a one-way approach. So as then you go to open it, it makes contact at this intersection here with the pilfer proof, and then retains the neck finish, or sorry, the tamper band on the neck finish, and then the bridges here begin to stretch and elongate and eventually fracture. Now, with any closure on the market today, there is a compromise, and that compromise is between good capping performance and good tamper evidency. Ideally, you want these cams to get good tamper evidency. You want these cams as wide or as thick as possible. However, there is a fine line. When you get too thick of a cam, then your capping performance suffers, because as you're applying, it's requiring the band to stretch even further. And what can happen is premature fracturing of the bridges, which is you may have known also as broken bridges. So ideally, you want minimal interference when you're applying the closure, i.e. here's an exaggerated line here I've drawn here on the cam itself. So minimal interference when you're applying the closure, and then maximum interference when you're removing the closure, so that there's maximum interference to ensure that all of the bridges break uniformly. And there's this compromise. And how do you achieve that? Because it's not like you can add material after the fact to ensure, a good capping while also having a good interference tamper evidency. And that's that compromise. And that is magnified even further when you consider that PET is more rigid relative to HDPE. So the ability for the material to stretch and deform is more limited than it is with HDPE. And that was the big challenge that we were facing when we were setting out on this course. And so how do you achieve this good tamper evidence without essentially a capping window? And this is what we came up with. So think of a featureless tamper band. So there is no cam on the band itself. So it's applied, there's no interference. Then we apply a secondary operation where we provide a directed heat source right at the band itself. And you can see that when that heat is applied, it actually shrinks the band right around the pilfer proof, almost like a cup. And that ensures that there is a good capping performance because there's no interference, and then a very good tamper evidency when you're removing the closure off the finish. So that was a simulation on how it works. Here it is in real time. This all happens, if you look at the image on the right here, you can see that all happens over the span of 1.2 to 1.4 seconds. So as the closure spins, we apply a directed heat source, i.e. a laser, at that specific area, and the band just shrinks around the pilfer proof. So we brought a prototype design, as shown here in the top left, to NPE in Orlando back in May of 2024 to prove out the concept. Now, this platform is capable of 15,000, so 15000 bottles per hour. We know that that's nowhere near the requirements of the industry. So we wanted to prove that it's capable first. And what we did is we had this setup where we had cap bottles unformed pass through the forming device and come out the other side, where we could actually give to consumers or attendees at the show booth and actually interact with the bottle. So we wanted to prove through this prototype that the process was actually feasible and possible. And at Drink Tech last year, we made it real with a scaled solution. Now, we know again that 15,000 bottles, can handle very, very niche, i.e., premium products. But the industry demands levels much higher than that. So the first industrialized solution that we showed at Drink Tech was capable of 45,000 bottles per hour. So 45000 bottles per hour. And we have plans to increase that further beyond 80,000 bottles per hour. So again, how does that technology work? The industrialized solution, well, here's a video of it running here prior to the show. So we call this technology the High Cap Secure. Again, backed up with our Advantage Plus Elite monitoring. So the bottles come in so they go through, this device is positioned on the filling line. The bottles come after capping, go through this device here with the timing screw, phases it properly as it goes onto the star wheel. The star wheel transfers, as you're seeing here, onto the carousel, which runs in a counterclockwise position. As the bottles are rotated in a clockwise position on the carousel, which is going counterclockwise, they pass through a heating zone where the bottles are actually formed. Those tamper bands are formed around the pilfer proof. And then it goes through our vision inspection that checks that the bottles are properly capped. There's no cock caps, that the bands themselves are properly formed, and then goes on from there through the downstream secondary lines for palletization. So it's a brief description of the industrialized solution. So if we look at typical capping defects, you can have defects around the shell, where you have high caps where not enough torque has been applied, cocked or tilted caps where maybe the bottle has been tilted on the line and then the closure's been misapplied. And then on the band side, broken bridges, which we got into a bit earlier, and you can also have tuck unders where the band is actually rolled underneath on itself. Again, not desirable. On the right-hand side, the approach that I've just described, where there is no interference on the band itself, are virtually eliminated during capping because there is no interference. The bands are just applied normally without any contact, very low stress on the bridges themselves until they're formed. So why do we believe that injection molding is the best approach for the PET closure? Well, it's really the design freedom. So being able to incorporate very challenging, complex geometries here, like in this case of this tethering design, you're able to incorporate that right into the slides themselves. So as the slides close up every cycle, when they open after a few seconds, the part's ejected. That part is ready for the capping line. It is no additional post molding operation is required to the closure itself prior to applying to the neck finish itself. Again, with the injection molding, it's very scalable, precise, and repeatable. Example here is shown is our high cap platform, which can do both HDPE and PET closures. We have three different clamping tonnages, and capable of cavitations from 24 all the way up to 96 cavities. But again, on the precision, the level of precision, so the software driving the operating system for the machine itself has a scan rate of 500 microseconds. So that is 0.0005 seconds. And in that time, every 500 microseconds, there is scanning that is occurring. So it's looking for how the position of the screw is. Is it in the right position to ensure that we're metering the proper amount or proper volume of material into each cavity? So 2,000 times a second, that operating system is scanning the position of the clamp of the injection unit, how much is being metered into the cavities itself. And the ability there is to really provide a shot-to-shot and part-to-part consistency that is unmatched in the market today. So I mentioned at the very outset that we're focused on the industry standard neck finishes as a starting point for the PET closure. The first one that we're looking at is the GME 3026, which is the 2925. So it's a very common neck finish that you would see in Europe, Middle East, Southeast Asia for still water. Now, this version is a little taller than your typical 2925, just to give it a little more grip zone. That was what some of the early adopters in our voice of customer were looking for. So we decided that we were going to start with, for the first launch, was the 2925, both in a non-tethered and a tethered format. So with the cycle time, the part is a little heavier. So there is about a 15% penalty on cycle relative to HDPE. And on the part weight, because of the mass density of the two materials, comparing a standard tall 2925 versus our HDPE equivalent, there's about a 40% weight adder. So on this closure for PET, you're looking at 1.9 grams, same whether it's tethered or non-tethered, versus about 1.35 on the HDPE equivalent. However, let me get into ways and opportunities on how we can further reduce that weight. So again, this design here, the tethered solution, fully compliant with the EU directive for tethering, 25 Newton pull force in both the horizontal and vertical directions, and the hinge itself must withstand 15 openings and closings. Again, this is the first format that we're proceeding with plans to introduce a smaller format, the 30-28, which is the 26-22 3-start, and then also the 30-25, which is a 38 millimeter 3-start. Our target there on the 38 millimeter is late Q2, so late May, early June timeframe for still water, and then aseptic mid-October when we were looking at having a solution available there. Now, here's where the rubber hits the road when we're looking at weight, and how do we really take out weight without compromising the user experience or the brand performance. And we heavily use here at Husky simulations to optimize the design for our closures, both mechanical FEAs and simulations, as you can see here, where this design itself is, or this image is highlighting the internal pressures of a closure under extreme heat and pressure. So we're showing here how we expect the doming to behave. And the critical part on something like this is that you still maintain a good seal between the plug seal and the inner bore diameter of the neck finish. Because if you don't, you're going to end up with liquid leaking out of the bottle as the internal pressures here grow. Also on the flow FEA, we're looking at how is the material flowing into the cavity? Are there dead spots? Are there preferential flows where one part of the closure is fully filled and packed out versus another that, say, hasn't been yet? So we look at there with the design, how do we optimize the design to ensure a very even and uniform fill? And what we do, and what I've highlighted here in the top, so this is a section cut of a typical 29-25 closure. We're looking at all of the features that make up that closure, whether it's the top panel, the plug seal, the sidewall, the threads, the cams, the bridges. Where is there waste in this? And waste meaning, where can I take weight out of the closure without compromising any form of the usability of the closure from a consumer standpoint or the performance? And we leverage this. This is an iterative process, but this allows us to design much quicker and get to market much quicker than a trial and error approach that maybe others are pursuing. And here's now where we can apply that to the PET closure design. So what I'm showing here on the left is a typical neck finish for a 29-25, so the GME 3026 standard. You have three thread starts, 180 degrees total thread length, highlighted here in red. And with the closure itself at a 1.15 gram, you end up with a total dispensing system weight here of almost 3.6 grams. So 2.42 in the neck and 1.15 on the closure itself. Now, because the PET is much more rigid than HDPE, we can leverage some of those properties to further lightweight at a dispensing system level. So lightweight not only the closure, but the neck finish as well to comprise the dispensing system. So what we found through our analysis is that we don't need 180 degrees of thread length times 3 for the 3 starts for the PET closure. We essentially need 130 degrees of thread length. Anything more, the additional 50 degrees is just waste. And what does that translate to? Well, it's that area here highlighted in the green dashes. So that whole area here is all waste. That's that 50 degrees that you're seeing here. So if we're able to remove that, we can actually shorten the height of the neck finish itself by an additional 3 degrees, or 3 millimeters, sorry, to end up with an overall finish height of just under 10 millimeters. That translates into a weight savings at the dispensing system level of just over 0.7 or almost 0.7 grams. So we're looking at a neck finish now from 2.42 to 1.7, and the cap itself about neutral relative to going from PET to to PET from HDPE. So what do you end up with? About 19%, almost 20% at the dispensing system level. One other key advantage, so not only do you have that very secure tamper evidence approach, you hear a very audible click when you go to open the closure for the first time. So I have here a tethered version, 2925. And when you go, hopefully you can hear it. So it's very distinct when you open it. And I think we've all been there where we've been using a commodity type water bottle, and we've opened it, and we were like, "Did those bridges break? I don't even know if I heard that. I definitely did not feel that in my hands. Um, can see that they broke, but did they break before? And maybe I better not consume that." With the PET approach, you definitely hear that the first time you open that. It's very distinct from an audible point of view, and from a tactile point of view, you feel it right away when you open it. And obviously, you can see it as well that the band has dropped. So, what we've also been active with is talking with a lot of the uh, associations that are representing plastic recyclers and the recycling industry. Here in North America, the APR, the Association of Plastic Recyclers, Recyclass in Europe, and also EPBP in Europe as well. So we've been working with them to ensure that our PET closure solution meets all of their guidelines. And they have, as you see here, design preferred with APR, full compatibility with Recyclass, and also with EPBP. And if anyone's interested, I'll have my contact info um, up at the end of the presentation, and I can send you those links that are highlighted there, the hyperlinks, where it says yes. So we've been evaluating a variety of bottle grade materials. So far, our closure works extremely well with Alpex Capital. This resin grade is available both in the Americas and Middle East currently. And again, very excellent injection properties, ejection properties. The forming, it performs extremely well. Now, we're also evaluating different grades of rPET and also virgin materials as well. And those are all underway. But right now, our go-to-market is with the Capital material, and we would love to be able to send samples out if you would like to do further performance testing and line validation. So again, you may be asking, okay, how does it perform? Well, we've talked at length on the tamper evidency and how it's unmatched in the industry, so I won't beat that to death. Very good on bottle drop, both on the base itself and also horizontally on the SST sealing, meeting the SETI standards and guidelines for no leaks at 25 psi and no blow-offs at 40 psi. We spoke about the application angle reduction, so we do not need as much application angle simply because of the rigidity of the material itself. Application torque and strip torque. Application torque within limits of existing. Typically water brands require anywhere from 12 to 17 inch-pounds, so consistently within that. Strip torque much higher than HDPE simply because of the rigidity of the material. And again, on the removal torque, initially when we went down this path, we saw that there was more of an affinity for the two similar materials to want to adhere to each other. However, we've been able to overcome that with some creative design approaches, both looking at how much preload we have on the plug seal, how do we reduce contact surfaces, and then also the use of slip agents as well. So on the capping, again, highlighted that earlier, very repeatable, stress-free. There's no interference as you're applying the closure to the neck finish, and then compliance with the EU directive for tethering. Again, as you can see here with this example here. Also looking ahead in Europe with PPWR and single-use plastic recycling mandates. Again, I just wanted to highlight two areas where I think this is really well aligned, meaning the PET closure. One on the design for recyclability, so simplifying the recycling streams. There's no additional separation required because the closure is made from the same grades as the bottle itself. So simply toss in the recycling bin and it's been optimized for recyclability. And then as legislation here on the PPWR advances requiring 30% by weight of a PET package by 2030 and expanding to 65% by 2040. Again, being the same material as the closure, and the fact that we've tested the Morris Sinkoff and also the other material here, just going back 1 second, the Far Eastern New Century RPET, that we're able to really help brands stay ahead of these recycling mandates as well, or even exceed those targets that are shown there. So if we look at the manufacturing matrix of what is different from HDPE, on the machine side, basically no change. The only change being a screw that is optimized for PET processing. But if you already have an existing high cap machine, you can remain with that. There's no new investment that's required on the machine side. Now, on the tooling side, you do unfortunately need to invest in a new mold for two reasons. One, the shrinkage is different when you compare PET versus HDPE, PET being much more stable. But if you have an existing HDPE high cap mold, you're unable to reuse that simply because of the shrinkage and the fact that we use pneumatic or electric servo-driven valve stems to actually shut off the flow. So both the cold half and the valve gate are required. Since the PET material is hygroscopic, it does require pre-injection drying. So a resin dryer is required. And then the TE former, which is then placed on the filling line. Other than that, there are no other changes that are required to the filling line, except capping chucks, which we always prefer that we have specific capping chucks mated to specific closures to ensure an optimal application and improve that capping performance. So on the TE former, the video I showed earlier, we're capable of 45,000 bottles per hour. We have on our roadmap to increase that throughput to 60 to 80,000 BPH, depending upon your specific needs. And then all of this is backed up by our Advantage Plus monitoring software, so that you can quickly identify any kind of potential issues before they become real problems. You can monitor the system and see that the closures and the application is performing as intended. So in summary, just to highlight some of the value propositions of the HiCap Secure platform, really the unmatched level of security is a very key criteria, and highlighted earlier the importance of tamper evidency to ensure that your product remains safe for all of those invested parties, whether it's the brand owner, the consumer, the retailer, the closure producer. The RE portion of our Secure Plus represents the indefinite recyclability of the PET material. And again, by having a mono material package, you're able to increase the yields, the bale yields of rPET as well, because the closure is the same material as the bottle itself. And then additional value drivers is really the stress-free application, so the lack of cams, so there is no interference as the closure is being applied to the neck finish. You have that design freedom that the slides allow. Additional lightweighting opportunities at the dispensing system level because you don't need as much thread engagement, so you can actually shorten the thread finish itself, along with the closure height, and save additionally in your material consumption. In the way things are going currently in the world with the geopolitical risks and any additional lightweighting that can be achieved is a good thing, both from an environmental standpoint and also from a cost standpoint. Compatibility with industry standard neck finishes, unless you want to take advantage of some of that further lightweighting opportunities, we can do both. Dust-free manufacturing approach, so since there is no post-mold scoring of the tamper band itself, all of the closure is finished in the mold. That contributes also to additional maintenance and cleanup in your factory environment. And then the improved barrier performance of PET versus HDPE. So I just wanted to conclude then with the three things that I was hoping that you could take away from this talk. One is our solution offers enhanced consumer security, improved capping performance because there is no interference on the band itself with the neck finish, and it's fully compatible with industry standard neck finishes. But if you have a custom neck finish that you would like to discuss or explore further, please feel free to reach out to myself or my colleague, Roman Spirko, who is the product manager for this. My contact info is here on the final slide. Reach out, and either myself or Romain will reach out to you and provide you with more information. So with that, I want to thank you for your time and wish you a good day. And again, thank you for the privilege of your time to sit with me here to go through this exciting technology.
Thank you very much, Mike. That was a very insightful presentation, and I'm sure all the delegates enjoyed hearing from the depth and the questions that they had. Many of the questions are answered, I'm sure, but I also have some questions which have come in from some important customers of yours or potential customers of yours. So I'd like to run through some of the questions if you like, right?
Sure.
So the first question is coming from a person, Mr. Yusuf Al-Manai. So his question is, how do you see the business case evolving for all PET closures in regions where recycling infrastructure is still immature? Is this driven more by regulation or brand pressure or true economic value? And that's a very valid question because I mean, that's my question. And so, Mike, if you can. Yeah.
So the key driver for the business case is really the material costs, right? From a financial point of view, there's also the environmental impact, where being able to keep that material in the circular loop helps as well. But being able to lightweight a PET, all PET package, depending upon what Mr. Yusuf's resin, what he's paying for resin is, I'm sure that we can develop a business case tailored to his solution, depending on some specific inputs on the what he's paying for utilities, what he's paying for resin, raw material, Again, the technology piece is a very small slice of the overall total cost of ownership and the ongoing costs, the OPEX for the package itself. Again, one other element that he did mention there was legislation, and that was one thing that we're looking at as well. Is plastics are certain organizations have made plastics a target, and we said, how do we further make our product offering? How do we enable that circularity and that circular economy in a very efficient way? And this was one way that we felt could improve that position.
Right. Okay, great. Dwelling on the same point, all PET closures, there's another question. How do all PET closures impact bottle-to-bottle recycling in terms of quality, in terms of IV degradation, and also the contamination compared to traditional HDPE closures?
That's a good question. So we don't see any impact from a negative perspective, because the materials that we are processing that I showed on that global map all have their bottle grade materials. So, IVs between 0.72 to 0.8. The MOPET and the Far Eastern have a higher IV. I think it's 0.8. So again, we're using, and this is where I challenge the attendee to also make sure that they're comparing apples to apples when they're evaluating some of our potential competitors in the market, that they're using and focusing on bottle grade PET.
Sure.
Because claiming, all of our experience showed that when we're applying the closure, whether it was a slit folded band or a molded interference, we were getting premature bridge breaking with the traditional approach. That led us down that path to having an interference-free approach. So again, long story short, we don't see any negative impacts on the IV relative to just using straight, if you were just using the bottle and going with an HDPE closure. So our PET closure, we don't see as negatively impacting the IV any more than the bottle would, or the neck finish, sorry.
Right, thank you. Again, speaking of IV, this is a question from Victor. He asks, in terms of the resin characteristics, what is the IV requirement or requirements?
Yeah, good question, Victor. Again, we're within the 0.74 to 0.8 range, and that's what we're evaluating. And if you have specific questions, I have my email address here that you can reach out. And if you want to know what the specific IV is of all of those materials that we're testing there, I can tell you that it's between 0.74 and 0.8. But reach out to me, and we can start the dialogue, and we can go into more details specifically on the specific IV for the different materials that we're evaluating.
Right, right. There you go, Victor. I think you need to stay in touch with Mike. So his details over there, Victor.
And if I can't answer it, for sure I'll involve more technical people that can.
Sure, sure. There's another very interesting question, Mike, from Ronald Wahibi. Ronald Wahibi is asking, why injection molding and not continuous compression molding?
It's a very good question, Ronald. So if I can, I think you're still seeing my screen, correct? Or you were, now you're seeing my desktop. Very, very good question, Ronald. What I wanted to highlight is with our slide approach that we've incorporated here, we can incorporate much more advanced and complex geometries into the closure design itself. So we get a much more sophisticated, I don't know how easy that is to see there. Maybe you can tell me, Ben, on the design itself. But things like this hinge area, and see here if I can zoom in.
Right.
Um,
Yeah.
but you can see like the tabs and the 45-degree angles here. I don't know how you would post mold slit something like that. Additional with the features here, eject something like that with all of the geometry that is sitting here. Um, that's why we believe that injection molding is the best approach to a PET closure.
Right. Okay. We have a few more questions coming in. One moment.
And again, Ronald, if you want to discuss that more, the merits there, feel free to reach out. Additionally, so there's no post mold operations required, like scoring of the band itself, so you don't create PET dust in your factory, which is always a contamination risk as well.
Okay. Okay. There's another interesting question, Mike, from Anand Sarkar. He asked, for colored closures, do we need change in master batch formulation?
It's a very good question. Yes, we have experimented with different colorants. However, that again, if the brand insists on this is what they would like to introduce, then this is something that we can work with them. However, then when you start to add colorants, you can pollute the recycling stream. So, especially if you're looking at something like a purple or, something there is like green and blue that I know here in Canada, there are brands that are, they actually are seeking that colorant so that they can tint their bottles more of a blue color. So here's one here that you can see. I got to put it in front, but a blue color that you can tint for. So yes, it can be done, and I can send you, if you shoot me an email, I can send you a picture of one that we've done. But it again, it pollutes the recycling stream, so you have to examine what are your motives for doing that.
Right. So there you go, Anand. You can reach out to Mike for more details.
And again, I can put you in touch also with our product manager, Romain, on this.
Right, right. We can take a couple more questions, Mike. There's one very interesting
Sure.
question. I'm sure that this is something which you have been sharing, and I'm sure that you have a good answer for this also. How easily can existing bottling lines integrate with your high cap secure, with Husky's high cap secure, plus without any major capex or downtime?
Yeah, that's a really good question. So the footprint on this, the industrial solution, I think is 4 meters by 8 meters, length and width. Height requirements, it would be within the existing. Again, this is the first approach. If you are working with an existing filler, whether it be KHS or Seidel or Crohn's, we can work with them as well, because phase 2 of this also is looking at how do we incorporate our technology within the existing footprint, whether it's a capping machine, where then we actually do the forming within the existing machine as well. So there's 2 approaches there. But we're at the very early stages there. But if this is something that you're interested in, again, please reach out and we can discuss either a standalone like what I've shown or in integrated. So again, if we look at timing, thinking we're looking at probably 1 to 2 weeks for integration and till we get up to speed.
Brilliant. Mike, I think we'll take one last question. It's very interesting. And
Sure.
we are currently running 1.4 grams of HDPE closure. What weight opportunities lie in converting to PET? This is from Ronald. He had asked a question earlier.
Yeah, yeah. Without knowing the actual neck finish, and what I would like to do is if we could get, the closure design, or if you could tell us it's, what finish, if it's a 2925, I assume it is. Our standard, depending on the height, again, it's hard to give an answer without knowing more of the background. Like, is it tall? Is he looking for a standard height? Or if we go to the extreme, as I showed here, and let's assume that it's 2925, that short height is 1.2 grams.
All right. Mike, if you allow me one last question, I definitely would like to ask. This is from perhaps one of your customers. Joel Shem from Berrycap is asking this question regarding removal torque performance. Since both the cap and bottle are PET-based materials creating inherent friction, does the removal torque change over the shelf life of the filled product due to factors like creep and relaxation or product interaction?
Yeah, on our testing that we've done, we've seen that the removal torques have still remained within limits. Now, we're experimenting with a slip agent as well, but also looking at key areas in the design itself, like similar to what I showed earlier on the lightweighting. How do we look at balancing the amount of interference that the plug seal has with the neck finish, the amount of contact surface that, say, the threads have? Is there ways to reduce contact surface there to compensate for the affinity that the similar materials have? So again, this is something that we've been able to achieve definitely with the use of slip agent, and then also looking at how do we incorporate creative design techniques, like I've shown we can do with our with all of our simulations, advanced simulation capability, and how do we leverage those to create a more optimal design. But we would love to work with you, Berrycap, as well, if you're interested in discussing this further. Again, please reach out, and if I can't answer, I'll get my colleagues involved.
Brilliant. Mike, I think we're running out of time and we have a few more questions. We're going to forward these questions to you to reach out to them directly.
Sure.
So, very interesting questions.
Please.
I think this webinar was very informative for all our delegates and for us as well. And I think we are moving the right direction here in the region. Lightweighting was a very important topic that we really touched for the need. This is a need of the hour now when moving from PET to rPET. And monomaterial, I think this is a very key momentum and key transition period that we are going through in the region. And I think this was pretty informative. And I think a lot of questions will still come, which we need to work closely with the industry. And it's a collaboration more than just bringing in something. I think we have to work with all the stakeholders to close the loop for PET recycling and lightweighting, monomaterial. I think so, yeah.
Yeah, and if I could just add one thing, Ben, to the audience. We're at the very early stages, right? I'm not standing here, and one thing that I omitted, we're starting with still water because that's the easiest application. We're starting to look at aseptic, hot fill, CSD. Those are on the roadmap as well, but they present an entirely new level of challenges, like that lightweighting that I showed. Okay, you can't do that with CSD because you need a certain amount of thread length. However, we're at the early stages. We see a lot of promise and opportunity for this, especially as a recyclability legislation, as you've seen with PPWR, comes into play. Again, we're excited about what's there. and what we've been able to accomplish so far, by no means have we solved it all, right? I want to make that clear, but we are on the path, and we have something that we feel is very unique in the market and is secure and enables lightweighting as well. Excuse me.
Absolutely. Absolutely. Thank you very much. I think that's.
I know we've gone over time and I've been chatty. Sorry about that.
I'm happy. I'm happy that a lot of very relevant and important questions came up, and that means that the industry in our region, the customers in our region, are really moving in the right direction, and I think that's really encouraging. It's no more a challenge; it's a question of enabling it. And as you correctly said, although we are in the early stage, but I think we are. I mean, in this part of the world, I would say quite a lot of bottled water companies moving in this direction. So that's a good sign. I think with closure companies also, but you're working in the same space. Really, that's the way to go. And very soon, I think we can achieve what we are talking now. All right, and we'll come up with a report on this webinar, and we'll also get some good questions from all the audience, and which we'll be forwarding it to you, so you can directly answer them. And we need to close the loop and collaborate more closely. I would also like to work with more brand owners who are also over here asking some questions, so we'll forward them as well to you.
Okay, yeah, perfect. And if I didn't answer your question or a question to the satisfaction that you would expect, reach out to me, and I can get other people.
No, your answers were perfect. Sorry to interrupt you. More questions which have come in is what I'm saying. So I'm talking about the questions still coming, and we're going to your questions, your answers were perfect. So coming up, more questions coming up. We'll forward it to you. And yeah, ladies and gentlemen, thank you very much for joining us for this webinar. I hope it was very useful for you. And stay in touch and send us any details that you want, or you can reach out directly to Mike. His contacts are still over there. You can just note down his email, and there's a QR code with his details. You can just note down and stay in touch with Mike directly. If you want to reach out to us, you can do that as well. Thank you once again. And this is Ben Daniel, the editor of Packaging Middle East and Africa magazine, saying goodbye, stay safe, and looking forward to seeing you all soon. And Mike, once again, thank you very much.
Thanks, Ben. Thank you. Thanks, everybody, for joining and staying late. Thank you.
Thank you.
Bye. Have a good day. Bye.
Thank you. Good day. Bye.